Hello, and welcome to today's e-showcase, Reliability and Maintenance Best Practices for Aeration Blowers. I'd like to thank today's sponsor, Atlas Copco, for sponsoring today's event. Our presenters today will be Paul Peterson and Gatlin Gold. Paul Peterson is Atlas Copco's Municipal Sales Manager for Central and Eastern United States. Paul has been working with municipal customers across the country for over a decade. His focus is on providing solutions for water and wastewater engineers, operators, and contractors. Gatlin Gold is Atlas Copco's Municipal Sales Manager for Western and Southern United States. Gatlin has over a decade of experience working with municipal customers and specializes in all aspects of wastewater project management from the initial specification all the way through to the installation, running, and ongoing optimization of the facility. And now, without further ado, I'm going to hand this presentation to our presenters.
Thanks, Regina. All right, folks, today we're going to be talking about reliability and maintenance for specifically aeration blowers, but most of this information can be applied to all blower applications as well. So, why are we here today? Well, a recent study by Atlas Copco revealed that nearly half of all plant operators in the United States had concerns about the maintenance and reliability of their blowers. Since blowers are typically critical in every plant to which they are installed, we thought it was important that we share some best practices regarding the maintenance and what to look for pre-purchase, what to focus on during regular operation, and how to guarantee the best reliability and efficiency of that equipment. So first, I'm going to cover some of the design features that add longevity to blower products. We'll talk about cleanliness and filtration, reducing heat and cooling blower systems. We'll talk about bearing designs, contact and non-contact styles, the differences between them. We'll talk about unloading blow-off and relief valves used to protect equipment and processes. We'll discuss coated rotors and corrosion resistance within blowers. And then belt drives, gearbox drives, and direct drives. Then I'm going to turn it over to Gatlin to talk about the different maintenance schedules for the different types of blowers. We'll talk about positive displacement lobes, multi-stage centrifugals, positive displacement rotary screws, and high-speed turbos. Then we'll discuss the importance of service plans and service scheduling, and options for remote monitoring above what we traditionally think about in terms of SCADA. So, should be some good content for everyone today. I'll start with those design features that we talked about. And remember that an ounce of prevention is worth a pound of cure, right? Maintenance is better than repair. Let's focus on maintaining our equipment so we can plan our downtime as opposed to having unplanned downtime where everyone's in a rush and in a panic. So first off, filtration. Filters have different efficiency ratings, whether it be MERV, ISO, ASHRAE, etc. These ratings indicate how well filters prevent the ingress of different sized particles. In general, more efficient equipment requires a more efficient filter. A rotary screw blower has tighter tolerances than a rotary lobe blower. The screw does not want to see any particles larger than 3 microns get trapped between the rotors, while the lobe can handle particles up to 10 microns without issue. Cartridge filters, like we have pictured here on this slide, have an elastomer seal at both ends that form an interference fit within the housing. Particles cannot bypass a cartridge filter. Panel filters, like we typically see in our home HVAC systems, right? We're all familiar. These work well under constant vacuum, right? When we're pulling a vacuum through that filter, nothing can get through it. There's a nice seal. However, most blowers start and stop at least weekly, sometimes daily, sometimes several times a day. When the blower stops, dust, pollen, and any other particles may fall off that filter and into the cracks in the housing between the panel filter and the housing itself. When that blower starts up again, it's very easy for the blower to suck those particles into the compression chamber before the filter makes that seal again through that vacuum. Those particles can bypass the panel filter. Now, for something like a multi-stage centrifugal that has large internal tolerances spinning at 3,600 RPM, it's not really much of a problem. But for a high-speed turbo blower rotating at 30,000 RPM, those particles can cause significant wear over a very short period of time. If that turbo blower is using sensitive airfoil bearings, the damage caused by filter bypass could be swift and catastrophic. Typically, a more efficient filter has a larger pressure drop. However, by increasing the surface area of the filter, the pressure drop is reduced. For example, most low blowers have a small spun-woven polyester element. They trap large particles efficiently, but have to be changed every 6 months. A screw blower with a pleated paper element has a much larger surface area. So even though it filters much finer particles, it only needs to be changed once per year. So it's important that the filter is designed for the specific product and the specific application. Without the proper filtration, you're going to have increased chance of failure, increased unplanned downtime, and increased maintenance. Next, we'll talk about cooling and heat. So in general, inefficiency of equipment manifests itself in heat, right? The less efficient something is, the more heat it puts off. So for example, the average PD low blower is 50% efficient. So if this has a 125 horsepower motor or a 90 kilowatt motor, then 45 kilowatts of heat are being rejected into the process in the blower room. That's a lot of BTUs per hour. A screw or a turbo blower have peak efficiencies of roughly 75%. That means that a 150 horsepower turbo emits 28 kilowatts of heat. So higher heat requires more frequent oil changes, or if there isn't oil in the case of a turbo, more frequent coolant changes. If oil is not changed more frequently in high heat applications, it will lose viscosity and not be able to lubricate those bearings and gears, leading to premature failure. That leads to unplanned downtime and high repair costs. Heat is even more critical in non-contact bearing applications like high-speed turbos. Most turbos use permanent magnet motors. The magnets within the motor windings will degrade over time with prolonged exposure to high heat. Manufacturers of lower cost turbos use process air to cool the motor before compression. This preheats the air before entering the blower and motor. This results in lower efficiency and can cause premature failure due to that excess heat. It also exposes sensitive airfoil bearings to high heat that can lead to deformation of their very precise geometry, which again could result in premature failure of that bearing and blower. Atlas Copco intentionally uses separate air streams for cooling and process air, as shown in this photo of a turbo blower here. The cooling air, this allows you to choose whether to duct the cooling air or to pull it from the room. Depending on your blower building's HVAC, one of those is likely a better choice than the other. More importantly, all hot exhaust is rejected out of a single separate cooling grate on each machine. This allows you to duct that hot exhaust out of the room in summer. If you add a manual or thermostatically controlled louver to that ducting, then rejected heat can be diverted back into the room to provide makeup heat in winter. Here's a look at the non-contact bearings I talked about in the previous slide. Instead of using oil like traditional contact bearings, ball and roller style, these bearings use either electromagnetism or fluid dynamics to levitate the shafts and prevent contact between shaft and housing, eliminating the need for oil. We see these in high-speed turbo applications. So magnetic bearings were introduced in high-speed turbo blowers first. they came in the 1990s from European manufacturers. This technology can be constantly levitated and actively controlled to prevent contact in almost all situations. Because there is active control of the shaft position, these blowers are more resistant to surge, giving them a wider range of operation or more turn down. The downside of this technology is it costs more than the airfoil. However, what differentiates Atlas Copco in this regard is our backup bearing. Atlas Copco uses a ceramic backup bearing that allows up to 5 full-speed crashes before they need to be replaced. With over 600 magnetic bearing turbos in operation, some for upwards of 18 years, Atlas Copco has never had to replace a set of bearings or backup bearings in our turbo blowers. Air bearings were introduced by Korean manufacturers in the early 2000s as a lower cost alternative to the magnetic bearing turbos coming from Europe. The limitation of this technology is the number of starts and stops, and that's due to the high-speed contact before and after liftoff. High heat and surge events will deform that thin metal foil we see pictured here. That makes it difficult to create that lift. If the shaft does not lift and the blower gets up to full speed, then you can have a premature failure occur. These machines are designed with the blower and motor as one core. If the bearing fails, then the entire heart of the machine must be replaced. This results in long periods of unplanned downtime with high repair cost. Instead, to avoid that, airfoil bearings should be replaced roughly every 1,200 starts and stops. This results in more frequent downtime, but results in lower repair cost and shorter downtime periods. So magnetic bearing turbos cost about 20% more on average, but offer the highest reliability of any blower technology on the market. So if reliability is your primary concern, then the airfoil bearings should be avoided in favor of the magnetic bearings. Now, every blower should come equipped with a relief valve of some type. Centrifugal blowers typically come with a blow-off valve that prevents surge during startup and shutdown. This is required for them to start on a pressurized header or against a full tank. However, most PD blowers only come with a pressure relief valve because they're not subject to surge. The pressure relief valve protects equipment in case maximum allowable pressure is exceeded. However, it does nothing to protect the equipment from the stresses of startup and shutdown. So Atlas Copco provides an unloading valve standard on every PD blower above 20 horsepower. This reduces the back pressure on the compression element itself, allowing it to reach full speed in an unloaded state. Once up to speed, the valve closes and delivers all the air to the process. During shutdown, the unloading valve opens as the speed is reduced to avoid high torque at low speed, preventing belt slip on belt-driven blowers that can lead to premature failure. Unloading at startup also reduces the inrush current to the motor. That reduces the electrical demand charges on some of the largest motors installed in the wastewater treatment plant. Right? Blowers are typically the single largest energy consumer. So if we can bring down that demand, that's a significant cost reduction. Unloading also results in lower starting torque on the drivetrain, extending the life of bearings in the blower and motor and belts or coupling elements. If frequent start-stop applications like filter backwash or SBRs, it's possible for the recommended number of starts per hour to be exceeded. So on screw blowers with integrated controls, there's actually a solenoid valve on top of this relief valve, allowing you to unload it on demand. So if you've already reached the maximum amount of motor starts and stops per hour, you can actually unload the blower to prevent excess starts and stops, prolonging the life of the equipment. Blowers compress ambient air. So even in dry desert conditions, there is some humidity present. During normal operation, water particles are passed downstream into the basin, right? We're not like in high pressure compressor applications uh, forming condensate while the blower is running. Typically, it all goes downstream. But once the blower stops, condensation begins to form on the rotors inside the compression chamber. Well, water corrodes iron and steel, which are the most common rotor materials. It's extremely common to see rush formations on uncoated rotors within a year or a few short years of operation. After prolonged periods of downtime, uncoated rotors can lock up due to that rust formation. They can be broken loose with a long breaker bar, but at that point, that element's running on borrowed time. You should really order a replacement element once it locks up. It will keep going once unlocked, but it's not going to last for long. Other common contaminants like trace amounts of H2S or chlorine that are commonly found in wastewater treatment plants will accelerate the corrosion process. So coatings on the rotors not only prevent that corrosion and eliminate the chance of lockup, but they also provide better efficiency by reducing the gap between the rotors and casing. This gives you a higher efficiency and a wider turn down, resulting in lower energy cost. So in short, coated rotors prolong equipment life, prevent unplanned downtime, and increase your aeration system efficiency. Belts are a low-cost solution for drivetrains. You know, generally with blowers, we see three types: direct drive with coupling, direct coupled to a gearbox to increase or decrease speed of the motor, and then V-belt drives to, again, increase or decrease the speed of the motor and blower. Belts are the lowest cost and they don't require lubrication. However, they are easily damaged by oil, grease, abrasive chemicals, and heat, all of which are found in wastewater plants. Gates Corporation is one of the largest manufacturers of belts in the world, especially in North America. Their website actually states that misalignment, worn sheaves or pulleys, and inadequate belt tension result in as much as 10% reduction in efficiency. Although properly maintained V-belts can run as high as 95 to 90% efficient at the time of installation, this deteriorates as much as 5% during normal operation. Loose or worn belts cause vibrations that can lead to premature bearing failure. Belts also impose heavy loads on shafts and bearings, requiring more frequent rebuilds of motors and blowers. As a trade-off, gearboxes have higher noise levels when new, but more importantly, they actually require lubrication, right? We need to oil and lubricate those gears. But the advantage is that gearbox efficiency is independent of ambient conditions, so heat, dust don't affect them. And their efficiency does not deteriorate over time. They're 97% efficient, and they provide exact timing, meaning exact speed control for precise application process control. When properly lubricated, gearboxes are extremely reliable and they're able to transmit higher speed and power than belt drives are. So for that reason, Atlas Copco uses a shaft-mounted oil pump on our gearboxes, especially in our rotary screw blowers. So whenever the motor is spinning, all of the bearings and gears are force lubricated in the entire drivetrain, and that oil is filtered and cooled, resulting in the highest efficiency and the highest reliability. On some lower cost products like load blowers, we still offer belts and pulleys because they're a very cost effective solution. And with that, I'll hand it over to Gatlin to talk about maintenance schedules, service, and remote monitoring. Gatlin?
Thank you, Paul. So regarding maintenance, let's see. So we're going to go through a few of the maintenance activities for the most common types of blowers, like Paul had discussed in our summary in the beginning. And just to keep things simple, I'm typically going to refer to 1 year of 24/7 operation as about 8,000 hours. So when I say annually or biannually, we're looking at generally 8,000 hours and 4,000 hours, respectively. So starting with the Trilobe positive displacement unit. Uh, Most blowers will have a short break-in cycle, which requires maintenance between 400 and 500 hours. This is mostly just to ensure that everything is working properly beyond the original commissioning of the units. Low blowers specifically require the most maintenance of any type of equipment. Typically, we can see things like motor greasing, oil changes, and belts to maintain efficiencies at 3 to 6 month intervals, depending on environmental conditions. If you have electronics on board, like VFDs or controls, we would also suggest cleaning electrical cubicles and checking connections, just to make sure vibrations haven't caused and can't cause shorts to occur. We recommend inspecting and checking the check valves annually, just to ensure that the seals are properly sealing to prevent backflow. And you'd also want to replace these units if they're damaged, and if they're not, we still recommend replacing them every 2 to 3 years, just to ensure that they don't become damaged and allow backflow to go through the machine as other machines are typically running. Other maintenance items to the 5-year point would include things like bearing changes, replacing blow-off valves, looking at things like the electronic fans, pressure sensors, and things like that to make sure they're in good working order. Looking at the screw blowers, we know that typically more efficient technologies, by their nature, require higher precision and have tighter tolerances. In general, there's just more things to keep an eye on with higher efficiency units. Now, the screw blower is no exception. However, the actual replacement or changing of components should be quite a bit less often as compared to the amount of checking that needs to be done. For example, on our units, we have the annual check and replacement of the air filters and oil filters. We also have oil change intervals every other year. You still have motor greasings for TEFC motors at every 6 months to make sure that they're properly lubricated. But there are no belts to change, and the onboard controllers help with the maintenance reminders and keep the monitoring of critical conditions so that you don't have to perform as many checks as you would with a unit without controls. We also have optional oil-cooled motors, which can increase efficiency, but they also have an IP66 rating, meaning that they can be directly washed and run in much harsher conditions as compared to TEFC motors. They also use the same oil for the gears and elements that we use that's filtered and cooled to lubricate the bearings on the motor, meaning that we can eliminate motor greasings as well with these types of motors. As expected, multi-stage, sorry. I have missed advancing slides. Apologies for that. So just a quick overview, we're going through the rotary screws that I just spoke about. And now we're looking more at the multi-stage, and apologies for that, but if you... Can anybody confirm if y'all can see or on the rotary screw slide?
Yes, you are.
Okay, thank you. Okay. So, and apologies for that. I will make sure that everybody gets a copy of the presentation so y'all can look through this as we go, but I'm going to keep moving forward in a reference to time. So, looking at the multi-stage screw blower, these units actually have a fairly low number of maintenance items. So it's typically just replacing the oil or grease in the motors and the elements, checking the alignment, replacing the air filters. However, these items tend to need to happen very often, which is like most of the time twice a year, and depending on the environment, can be down to 4 times a year or every 3 months. The HighSpeed Turbo blower offers the lowest maintenance of any type of unit. They typically require annual filter changes and water or coolant changes anywhere between 2 and 5 years. Beyond that, down the road are some items that are typically not thought of when looking at high-speed turbo blowers, which are things such as replacing cooling fans, water pumps, uh, other appendices like valves and actuators, which can be anywhere from 10 to 15 years down the road. Again, all of these items are recommended to prevent failure from happening rather than the expected lifetime, which should last the lifetime of the machine. So these are a few things we commonly see. This picture here on the left shows what happened to a high-speed turbo blower that used a panel filter instead of cartridge filters. As you can see, there's quite a bit of dirt involved in that machine there, and with the tight tolerances of the high-speed turbo that was in, it just was not a good combination. The center picture is a picture of a lobe unit that I saw when I was on site, and they had it down for about a month because the belt had broken and they just hadn't had time to replace it. When they put the new belt on, the unit was locked up and they had to pull out the good old mucky wrench to get it moving again. And then here on the right, you can see what happened with a washable filter that was installed on a high-speed turbo unit. They washed the filter and put a few extra holes in it. The mud that had clogged up was actually tearing the filter apart when they washed it. So it was allowing larger particles to go through, and that was chipping high-speed impellers. So now that we've seen some of the most common maintenance requirements, we can talk a little about scheduling service and service plans. So, service plans are critical for maintaining efficiency and keeping a long-lasting, reliable blower. Whether you do it yourself or contract service out, there are many different requirements to look at. So if you want to do this yourself, you have to evaluate if you have qualified personnel that can handle the service requirements. And they would also need to make sure that they have the time available to schedule and perform the maintenance on the units. If your facility runs anything like most we encounter, finding that time can be difficult, as most of us, even in our industry, are stretched for time because we are doing way too many tasks. They would need to be able to evaluate and maintain items that require the maintenance. They'd have to order parts if any of these items look like they could fail soon. And they would need to be available for service whenever the scheduling occurred. They'd also have to keep up with the records of the machine and make sure that they were available for other personnel if your specific blower personnel was not available to work on the blowers in the day it needed to have service. So having all of these different requirements line up is possible, but however, in today's world, unlikely which is why the column on the left here is quite a bit larger than the column at the right. And what these columns represent is the maintenance required by customer or done by customers versus using the manufacturer to perform maintenance. Sorry, I was trying to skip that slide because it was one that we deleted and actually didn't say in the presentation. So what is the importance of a service plan? We collected data over the last 2 years looking at customer satisfaction for customers that had service plans and didn't have service plans. The differential was actually 20%. Service plan customers were 82% completely satisfied, which leads us to the 5 reasons that you would want a service plan. So at Atlas Copco, we actually have a dedicated service scheduler. So when you call, you're going to be talking to the same person. So having a plan will increase the priority of getting the work done, and having the maintenance scheduled proactively instead of reactively means less downtime. Pricing is fixed, negotiated up front, so anywhere from 1 to 5 year intervals, which in today's economy can be a major advantage. With remote monitoring services, we can also schedule technicians or service to happen without much involvement from the customer other than confirming which dates and times are best for you and when you're available. So all of this leads to the fact that if you don't schedule time for maintenance, your equipment will schedule it for you. So now we'll look a little bit deeper into remote monitoring capabilities. So we all live on our phones these days, so it's nice to have the option to keep you keep your blowers on them as well. With optional remote monitoring, you can get info sent straight to your mobile device. At a glance, you can check uptime, energy, efficiency, and overall machine health. With different style plans, you can get reports as well on the machine status and energy consumption. We're also able to mirror what you see on your machine with our technicians at Atlas Copco, as well as on your phone. With this mirroring, we can assist with diagnostic supervision so that we can see what's happening as you're seeing it happen. This allows exceptional troubleshooting and assistance in most cases without needing a technician on site. With advanced controls connected remote monitoring, we have the ability to see more information than ever before. The controls can also enhance the unit's reliability automatically by monitoring key parameters and modifying them to avoid potential problems. Multi-unit control can also be used to dictate the most reliable and efficient setup, which can automatically keep the hours similar between the units so that when you have a service technician come out, they can service all of your units at one time. This equals less trips, less cost. So, we can also enhance the reliability by automatically switching between units if any of them have issues. So, ultimately, a big part of reliability is getting the best product for your application. Starting with the plant's range of required flows and pressures is a good start, but some of these other questions can help identify potential problem areas and allow for advanced planning to reduce risk in determining what's right for you. Application location, required noise level, operational characteristics such as the amount of time the blower runs, and the load balance are all useful info in determining which type of unit would be best for you. Regarding service planning, does your plant have a maintenance team qualified to work on the equipment? And are they on site 24/7? Do you have, or do they have to wake up in the middle of the night and take a trip to the plant? So these are all key factors in determining the best equipment for your needs, and hopefully allows you to determine the most beneficial way to keep your plant operations running smoothly. Did we have any questions?
This was great. So we don't have any in the chat at this moment, but I would encourage everyone to go ahead and take that opportunity to make sure your two option is on everyone and chat your great questions for Paul and Gatlin. Paul and Gatlin, if you all have some other things that you want to cover really quickly, please take this time to do so.
No, I think we tried to leave enough time for questions, and if anybody
Yeah, there
has
was one
anything, just
thing I
let
was
us know.
going to address. Gatlin, I think you responded in the chat, but someone was asking specifically about geared centrifugal blowers. So Gatlin had mentioned that due to the time restraints here, we didn't include those in here. And the reason is those are typically only found at the largest 1% of plants. And since the other blower types are much more common in this industry, we felt that if we had to trim one, that would be the one that we skip.
Perfect. And then you do have some that are coming in. So you've got for the HighSpeed Turbo maintenance schedule, was that for any or was it specific to magnetic bearings? Any changes for airfoil bearings?
Yeah, so the schedule we showed was specific to magnetic bearing units, since we don't carry air bearing units anymore. But the things that are different for air bearings is we would definitely require a planned maintenance of bearing changes, depending on how many starts and stops the units have.
Okay, perfect. And how can one be sure an existing air filtration system rolling filter is adequate for a high-speed turbo blower?
I can field that one. I don't know that I'm familiar with a rolling filter per se, but essentially each manufacturer should have uh, filtration requirements and be able to provide those to you before you purchase that equipment. And you should be able to verify with the manufacturer of your filtration system or whoever you purchase your filters from whether or not it meets or exceeds the efficiency and particle size specified by the equipment manufacturer.
All right, perfect. Do we have any other questions that want to come in before we go ahead and close us out? We've got just a few more minutes open for our attendees to ask some questions. All right. Well, Paul and Gatlin, if you would, oh, here we go. We've got one. Any concerns or schedule adjustments if the blower is on the on the ocean salt air?
I believe that's what we would call a slightly harsher environment. So it would just need to be evaluated, how much the uh, items on the maintenance schedule look at the original maintenance intervals. And if you see that they're more deteriorated, or if the machines have controls that can let you know um, what's happening there, then we would look at advancing the maintenance schedule.
Yeah, and to elaborate on what Gatlin said, we have some experience with many installations around the Gulf Coast in particular. And if they're outside or, they're exposed to that salt air, we typically offer a higher resistance coating on the enclosures to prevent any corrosion of the sheet metal over time, which will protect everything inside the enclosure. And then in most cases, we also offer a pre-filter option, basically two-stage filtration. One would be sort of your wet salt air filter, and then the other one would be inside the machine, more your fine filter, handle the regular particulates.
Okay. So has Atlas Copco looked at biogas-fired blowers at all?
Yes, we actually, in our Houston product company, provide natural gas, biogas, engine-driven, turbine-driven compressors and blowers. But it's not something that's a standard product. Every one of those would be engineered to suit specific clients' needs. But if someone has a need for that, then we could definitely assist you with that.
Great. And can the standard ball bearing bearings be changed out to magnetic bearings?
The quick answer to that is not typically, but I guess I would need a little more clarification on that question. Are you
Well,
talking
Michael,
about which types of units would you be talking about, Michael?
yeah, so if you want to clarify in the chat, Michael, we'll go back to you. But for now, do you have a PTC 13 compliant test stand, and where is it?
Yes, we do, and that is in Houston, Texas.
Okay. And what are the typical cost for a service plan?
Paul, can
So
you help me on that one?
typically, yeah. So actually, service plans are very, very specific to the exact model, the size, and your number of running hours per year. So are you running each machine 50% duty, 100% duty, intermittent duty? And then obviously, based on the type of equipment, you'll have different parts. And then we also offer, just parts, preventative maintenance, extended warranty, all the way up to total responsibility, which guarantees no unplanned downtime and includes overhauls in the price of the plan. So we have a whole range of options for every piece of equipment. If you have a specific scenario, we'd be happy to engage with you and talk about the different options and pricing for you.
Perfect.
Yep, I see Trevor said total responsibility. Again, that's going to be the highest price plan, but it varies wildly by the type of equipment and the size and your running hours.
Perfect. And then I see that Michael has replied, are bearings interchangeable?
Generally, no. For any given product, whether it's a contact bearing or non-contact bearing, there's a specific bearing size for those contact bearings, the ball and roller, and you typically need to replace them in kind. And then same thing on the airfoil and magnetic bearing turbos. Once those machines are in place, you typically need to replace with the exact same bearing each time. There's not usually retrofits available, at least that we're aware of.
All right. Well, I think that is going to actually take us on out to the end of our presentation. We've got about 1 minute left. So I just want to take this time to thank Paul and Gatlin for a great presentation and to thank Atlas Copco for sponsoring today's event. This actually concludes today's e-showcase. Thank you all for attending. The recording will be available at weffiresguide.wef.org. We will send all registrants an email tomorrow with that link. And please visit our event calendar to sign up for a future e-showcase. Thank you, Paul and Gatlin.
Thank you, Regina. Have a great day.
Thank you, Regina, and thank you, WEF, for having us. And thank you all for attending.